Guten Morgen. Good morning. It's good to be here. I'm delighted on the behalf of the MIT Initiative on the Digital Economy to also welcome you. We're very happy to be able to help co-sponsor and organize this along with Jeff Parker and others at MIT. We've been running a platform summit in Boston and Cambridge for the past few years, and I think it's a real milestone that we're now doing it here in Europe. And as Peter was saying, there's a challenge ahead of all of us to bring Europe into the platform economy further along. There are so many core capabilities here that aren't being fully harnessed. And I want to say, while Peter, I think, may have frightened you a little bit about some of the challenges, I also want to say there's some huge opportunities because these are still very early days in the platform economy. There are, yes, some trillion-dollar companies, but I think there are going to be many more created in the coming decades. And that's because the technology is still evolving quite rapidly. We have some amazing general-purpose technologies. This is what economists call them, these very powerful technologies like computers and the internet and artificial intelligence that not only create productivity and innovation by themselves, but also enable a cascade of complementary innovations. And let me just grab this here. These complementary innovations are still being invented and developed over time. And often it takes 5, 10, even 20 or 30 years for them to fully play out. Key is not simply the technology per se, but it's understanding the new kinds of business models and business processes that are created. And that's what I'm going to focus on in my talk today. I'm going to talk about not just the platform revolution, but really how it's part of what Andrew McAfee and I call a triple revolution that involves minds and machines, products and platforms, and the core and the crowd. But to set the stage, let me describe an earlier general purpose technology that became very important in Germany, the United States, and the world about 100 years ago, back in the early 1900s. And that was, of course, not the internet, but it was electricity. And electricity was used to reinvent industry and manufacturing. Historians who looked at how electricity changed performance, though, were quite surprised. What they found was when they looked at the first introduction of electricity in factories, they found that it did not increase productivity measurably. In fact, productivity did not increase for about 30 years. 30 years, think about that. That's how long it takes for a generation of managers to retire. And that's not a coincidence, because the real power of electricity was not simply from buying electric motors, but it was from rethinking the way work was done. Before electricity was introduced in factories, factories were organized typically around a steam engine or sometimes a water wheel, a central power source. In order to distribute that power, they had long crankshafts or sometimes pulleys and wheels that would power all of the equipment. Now, you couldn't make the crankshaft too long or it would break. So the equipment was clustered as close to the central power source as possible, with the equipment that needed more power closer to the steam engine, and then some other equipment further away. And they were fairly clever to minimize the radius. They not only had it on one floor, but they had it on multiple floors, so they were up and above. These were dark, dirty, dangerous factories with lots of spinning wheels. Then they introduced electricity. They took out the steam engine, and they got the biggest electric motor they could find from a company like General Electric, and they put it in the middle. They hooked up the same pulleys and crankshafts, switched it on. Was that a big improvement in productivity? Not really. Not much really changed. Well, fair enough. They were retrofitting factories. Soon they started building entirely new factories. What did the new factories look like? Exactly like the old factories. They took the same blueprints. Some architect, perhaps, or engineer, perhaps from MIT, took the blueprint, took his pen, made a big X through the steam engine and said, put electric motor instead. He said, here, go build that. And they built a new factory just like the old factories. Was there a big improvement in productivity? No, it really didn't change things much at all. Now, you might think, well, skeptics at the time maybe might have said, well, electricity is kind of hyped. It's overrated. It's just not really making a big difference. We know that would have been completely wrong. Electricity is a revolutionary technology. The problem was people weren't taking full advantage of it. After about 20, 30 years, according to historians like Paul David, they started building, finally, a new kind of factory. And the new factories did not look like the old ones. The new factories looked more like this. They were single-story factories where each separate piece of machinery had its own power source. Electricity is portable power. You can make electric motors big, you can make them small, you can make them medium. Each piece of equipment had its own power source. This is called the unit drive system. There's a big debate if you read the literature around the time about how to set things up. And once you went to the unit drive system, you had much more freedom about where you located equipment. Did you have to put the ones that needed more power closer to the electric plug? No, of course not. You could put them anywhere you wanted in the factory. So how did they arrange things? Well, they started arranging them based on the sequence, the flow of materials, the sequence of production. And now, did that increase productivity? Oh yes, tremendous increase in productivity. Doubling, even tripling of output from these factories. So the lesson is not that electricity was a failed technology. The lesson is that amazing technologies don't deliver business results unless you rethink how you organize your business. And that's hard. That takes creative management thinking. Sometimes it takes a generation of managers to retire, but we're hoping we can speed that up by understanding some of the principles of this new revolution. This one is triggered by some amazing technologies, and it's even more important because it's not a single revolution, but it's what Andrew McAfee and I call a triple revolution. And I'm going to touch on all three parts of it, but we'll really focus on the platform component. The three components are a shift from mind to machine for decision making, from product to platform for revenue generation, and from the core to crowd in terms of where innovation is centered. So let me touch on each of those elements in turn, starting with the mind to machine revolution. And this really builds on my earlier book, The Second Machine Age, also with Andrew McAfee. And we call it the Second Machine Age because the first machine age was a powerful change in society when we started using machines to do the work of our muscles, to do physical work. The steam engine, electricity were both examples of machinery replacing human and animal muscle. Huge increases in living standards, ultimately, over a period of a couple hundred years. The second machine age is using machines to help us with our brains, our cognitive functions. And the second machine age itself comes in two waves. The first wave, which we are well into, it's been going for 30, 40 years now, is teaching machines what we know, programming machines. When you think about it, many of you in this room, I'm sure, have coded computer programming. And what is coding? Coding is codifying knowledge, taking what you know about how to do something, writing it down in extreme precision. If you write even one word or comma incorrectly, the program won't run effectively. But if you can code it down, you can get the machine to do it. And the reason you can do that is because once you codify it, you can digitize it. And once you digitize it, you can replicate it. And that leads to some staggering economics, unlike anything we've ever seen on planet Earth before. In particular, you have these economics of, yes, it's costly to initially codify it, but once you've done that, you can replicate it for virtually zero cost. In fact, there are three important adjectives that describe the digital revolution. You can take these code, these programs, and replicate them at almost zero cost. Each copy can be a perfect, exact replica of the original. There's no degradation. And each one can be transmitted anywhere on the planet almost instantly at the speed of light. So these new goods and services are free, perfect, and instant. That's not the way we describe things made of atoms or traditional services, but it's standard for the digital economy. Those are some very powerful economics, and they've given rise to enormous wealth creation over the past 20 or 30 years. Powerful as that is, it faces some important limits as well. And the limits are what Michael Polanyi calls this Polanyi's paradox. And that is that everybody knows more than they can tell. We know how to walk upstairs or ride a bicycle. I know how to recognize my mother's face, but it's very difficult, probably impossible, for me to write a piece of computer code with step-by-step instructions on how to do any of those functions. And if we can't tell or explain what it is that we want to have done, how can we hope to codify it? We can't. And that puts a limit on the kinds of things that we can get machines to do using the traditional first wave of the computer age. Fortunately, over the past 5 years, past 10 years, there's really been a revolution taking advantage of a once obscure field called machine learning and deep neural nets that is now blossoming. And this is what I sometimes call the second wave of the second machine age, which is not machines that we teach exactly what to do, but machines that learn on their own how to solve problems. And they learn that by being given large amounts of data. This is a category, part of artificial intelligence, and particularly this very rapidly growing field of machine learning. And the part of it that's growing the fastest, that's really getting most of the benefits, is deep learning, deep neural nets. Peter mentioned a company that was working in this area. It has led to just breathtaking improvements in so many different areas. For instance, we've crossed some very important thresholds in vision. I talked about recognizing faces. Any of you who have Facebook accounts know that it will recognize the faces of your friends or your relatives. It knows who they are. Face recognition has become ubiquitous, but actually it can recognize all kinds of images now. There's a big database that Fei-Fei Li at Stanford created called ImageNet. Has 14 million different images. Here are 4 of them. And each of these images were labeled by humans initially, but now machines are able to recognize them with better and better precision. The very steep part of the curve there, the blue line where it's getting much better, that was when Jeff Hinton and his colleagues in Toronto introduced deep learning techniques to image recognition. And it became dramatically better very quickly, just in a few years, to the point where it's now about 97, 98% accurate. In fact, it's so accurate that sadly they have ended the ImageNet competition. They no longer do it because they feel like machines have essentially mastered it. By comparison, the red line there, humans are at about 95% accuracy. We're pretty good, but we're not perfect. I don't recognize all the different, say, species of dogs or types of antelope. The machine can recognize them. We can't. So in this area, machines are beginning to achieve not just human-level performance, but even superhuman-level performance. And this is valuable not just for Facebook or for ImageNet, but for things like medical diagnosis. You can have these images trained on medical images from radiology or pathology or dermatology. And in each case, articles published in Science and Nature elsewhere have shown that the deep learning technique is matching or surpassing human experts in these areas. And they do it not by having us teach exactly what to look for, but instead by showing many, many examples, hundreds or thousands or hundreds of thousands in some cases, images of these have cancer, these images don't have cancer. You, the machine, figure out what the difference is. How do you identify them? And they have not only recognized the same things that pathologists learn to look for after 10 or 20 years of training, but they identified a number of new features that no one had recognized previously. These techniques can be used in all sorts of areas. We're working with a team at MIT that's using them to recognize real estate pricing. You can look at images from Google Street View, the cars that drive by and take pictures, match them up with housing appreciation, and it can predict which homes are likely to go up in price and which ones aren't. So there's so many different applications. Peter mentioned machine translation. We just wrote a paper, my colleagues and I, about 2 or 3 weeks ago, where we looked at the economic effects of machine translation. And we were surprised at how big the effects already are. On eBay, they introduced a machine translation system. And what you can see is that as they introduced it for each pair of languages, the trade between those countries increased dramatically. Here's the example for Latin America when they introduced Spanish. And previously, the blue and the orange line are roughly on the same place. But once they introduced it, you can see that the trade with Latin American companies went up quite dramatically compared to the other countries. And that was because of the machine translation, making it so much easier for people to communicate with one another. Well, I could talk a lot more about the AI and machine translation and machine learning revolution. Let me touch briefly on a second revolution and then get to the platform revolution. The second one is shifting from the core to the crowd for innovation. A good example here is what my friend Karim Lakhani described. He did his work as his PhD at MIT, and now he's at Harvard Business School. And he described a problem that the National Institute of Health in the United States had. They needed to sequence the genome of white blood cells as it changed over time. And the very smartest, best people at the NIH could do this in about 4 hours with, what is that, about a 75% accuracy rate. That's that little black triangle there. They knew they needed to do better, so they turned to Harvard Medical School. And Harvard Medical School had also some very smart experts in biology and gene sequencing. And they were able to bring it down to about 1 hour with a slightly higher accuracy rate. But that still wasn't good enough. So they introduced a contest on Topcoder to tap into all the brains around the world who might have an idea of how to do it. And many, many entries came in over the next 12 weeks. And these are all these circles here. Many of them were quite bad, some of them slower, some of them less accurate. But look at the orange dots up there, the cluster up there, the orange circles. All of them had higher accuracy and faster time. In fact, the very best one, the top left corner, completed the sequencing of the genome in 10 seconds. That's a logarithmic scale on the bottom. I turned to Karim and I said, I think there's an error in your paper. You said 10 seconds. That can't possibly be true. The experts at the National Institute of Health took 4 hours. And he said, no, that's not a mistake. That is true. And I said, how could they possibly do it so much better in just 12 weeks? And he said, it's not because they were experts in gene sequencing. In fact, it's because they were not experts in gene sequencing. They came to it from a fresh perspective. They were experts in fractal geometry, in seismology, in other fields. And to them, this was actually a very easy problem, one that they'd been solving for 20 years, but you had to think of things in a fresh way for gene sequencing. I said, well, that must be your best example ever. And he said, actually, it's fairly typical. When you send things to the crowd, and you will find people who think differently, you can very frequently find people coming with a new perspective, solving the problem orders of magnitude more effectively than the own in-house experts had been doing it. And it's not just these top-coder examples. Wikipedia, when you think of it, is crowd-based. Obviously, we all can contribute to that. Google, they have a lot of experts in Mountain View and elsewhere, but the real power of Google comes from the link structure of the internet. Every time you link to a web page, you are voting which page should be higher in the rankings. And Google uses all of our collective votes to decide which pages will be at the top of their search engine rankings. Or Kaggle constantly runs competitions for this sort of thing. Let me now get to the third revolution, perhaps the most important one, and that is the platform revolution. As you've already heard a moment ago, the biggest, most valuable companies on the planet are all platform companies. Every one of these companies is a platform-based company. Apple, at the top of the list, Peter showed the chart of that, but the others as well. The other thing I noticed about them is that none of them are European, but we can change that over time. There's nothing inherent in that, of course. Let's talk about the first one, Apple, which is at the top of the list, worth now just over $1 trillion. This is data from the summer. On your table, there's a book, Machine Platform Crowd. If you turn to chapter 7, here's the first few lines of that book. You don't have to do it now. But it talks about how Apple became a successful platform company. Peter showed you the chart where the market cap started soaring. Well, what's interesting, the history of it is quite remarkable because Steve Jobs, perhaps one of the most brilliant CEOs in history, was actually opposed to making Apple a platform company. He tried to stop them from becoming a platform company. Fortunately, he failed, but initially he wanted to keep Apple focused on controlling all of the apps from top to bottom on the iPhone. His team persuaded them to eventually open up the iPhone platform to other apps, and on a weekend, they introduced it. I think it was in 2008, and by the end of that weekend, they had 552 apps introduced, and I think it was 10 million downloads within just that weekend. So it just took off tremendously. And soon thereafter, they had 100 million, then 1 billion downloads. And of course, now we know that the real power, the reason that people buy this is not simply because it has a nice screen or form factor. It's because of all the apps that we can run on it, so much creativity that even the smart people at Apple wouldn't have thought of. It's all the rest of the planet that's contributing to those apps. And this has made it a tremendously profitable system, making more money on their hardware, their service, and their platform. Some people say, well, but now Apple is so huge, it's capturing 100%, all of the profits from the smartphone market. I went and checked, and it's actually not true that Apple captured 100% of the profits. In 2016, they actually captured 103% of the profits. So they got more than 100% because their competitors were losing money to keep up. Since then, Google and Android have introduced a competing platform that's doing quite well as also, but this platform economics is just incredibly powerful, and it has destroyed the companies that weren't as effective at playing in the platform game. And it's not just big public companies like Apple. You see startups from fresh, not even publicly traded, like Uber. I was just in China and met with the folks at IDE, which is just passing Uber now in terms of the platform there. Now, it's interesting to understand that the way that Uber and IDE work is not that they simply have one app, but that they have two different apps. And this is a lot of what drives the performance of it. With Uber, we all, if we want, we can get the consumer app and call cars, but the drivers have a different app. And that doesn't call cars, that gets them passengers. And the power comes from the synthesis of these two. It's really part of the network revolution. And First I'll explain that most of you already know simple network effects, which is that more users lead to more value, which leads to even more users. So for one-sided networks, like the telephone network, like the fax machine, like WhatsApp, we care about how many other people are using the exact same platform, because the more people that use it, the value grows up disproportionately, more than linearly. In fact, it grows quadratically with the square. This is called Metcalfe's law. When you double the number of users, the value goes up about 4 times. So that's why networks tend to have these winner-take-all effects. More and more users lead to disproportionate growth in value. But I said that Uber had 2 apps, and that's typical of platforms. Platforms are two-sided networks, or sometimes multi-sided networks. We have the driver app and the user app. And I don't really care how many other people are using the user app. For me, the value comes from how many other people have the driver app, and vice versa. So it's kind of an unusual network. With a network, you don't care about the people using the same app, you care about people using the different app. This leads to some strange and often very counterintuitive economics. Similar thing happens with credit cards, MasterCard or Visa or the other credit cards. There's a product for the consumers, and there's another product for the merchants. Now, initially, when MasterCard introduced their product, they charged both the consumers, sometimes hundreds of dollars for the card. They charged the merchants for processing. But then they began to understand the economics of two-sided networks, this credit card platform. Today, most of us don't have to pay for a credit card if we don't want to. So we can get a card for free. In fact, there's a price that's lower than free that many credit cards charge. They charge negative prices. They pay me to use the credit card. Every time I make a purchase, I get frequent flyer miles or cash back or other kinds of rewards. So they are paying me to use their product. Now, normally that would not be a very profitable business model to sell something for a negative price. But when you have a platform economy, this can be a profitable system. Why? Because the demand from the opposite side depends on how many users there are on the first side. So in the case of credit cards, the more users there are of the credit card, the more valuable it is for the merchant to sign up. And that means that MasterCard can make more money from the merchants. Similarly, with the Uber and the riders, there's 2 different sides. And every time we look at these platforms, we see that the core of it is the economics of two-sided networks. People like Jean Tirole got a Nobel Prize for understanding the economics of two-sided networks. We describe it in more detail in the book, and I know that Jeff and Marshall describe it in their book, but the economics of it often lead to these unexpected effects, and you need to understand them well to know how platforms can succeed. And it's not just two-sided. In many cases, it's multi-sided. So if you look at the Apple ecosystem, not only is there a synergy between the phone itself and the different apps, but the different apps often have synergies among themselves, and they lead to these effects. And this turbocharges the network effect in a much more powerful way than the simple single-sided network. And that's why we have this very rapid growth of these networks. If you are effective at curating this platform, if you know how to manage it, price it correctly, know which part you lower the prices, where you raise the prices, and how you maximize the interactions, you can create a very powerful platform economy. And this creates a feedback loop in each of the examples that we've looked at that increases the value. So let me just sum up by saying we are really now facing a new grand challenge. These network effects are so powerful, these platform effects are so powerful that we often get winner-take-all markets and increasing concentration of wealth. And over the past 20 or 30 years, due to the machine revolution, due to the platform revolution, and due to other changes in technology, many people have used these technologies to increasingly concentrate wealth. And inequality has gotten much more extreme, and economic power has gotten much more concentrated in most global economies, in the United States, in Europe, in China. But these same technologies can also be used to create shared prosperity. And that's why at MIT, in addition to supporting the Platform Summit, we also have something called the Inclusive Innovation Challenge. And we just gave away $1 million last week to companies that are using the technology to create more broadly shared prosperity. We had contestants in Africa, Asia, Latin America, North America, and Europe. In fact, the European winners, we had that contest right here in Germany, in Darmstadt, Germany. And the grand prize winners the grand winners from each of those regions all came to Cambridge for the final finale just about 10 days ago. And so I want you all to think about how we can use the technology not only to create prosperity and create trillion-dollar companies, but to create shared prosperity, to use these same technologies to benefit the many, not just the few. Thank you very much.